So in this problem, we're told that if C of x is the cost of producing x units of a commodity, the average cost per unit is C of x, which equals uppercase C of x over x, and then consider the cost function uppercase C of x given below. So uppercase C of x is going to be equal to 54,000 plus 200x plus 4x to the 3 over 2. So let's start with A. Find the total cost at a production level of 1,000 units. So basically, to solve this, we just need to plug in 1,000 into our cost function. So if we go ahead and do that, 54,000 plus 200 times 1,000 plus 4 times 1,000 to the 3 over 2. You should get, if you plug that in your calculator, 380,491.1064. But we're rounding to the nearest cent, so that means we got to round to here. So this 6 is going to make it a 1. So that's going to be the answer to A. And then for B, what we want to do is just, for B, basically all we got to do is take this number and divide by 1,000. That'll be our answer for B. So we just got to do 380,491.11 and divide by 1,000. So what you're going to get is 380.49. And so that's going to be the answer to B. And so now what we want to do is find the marginal cost at a production level of 1,000 units. So in order to find this, what we want to do is just take the derivative of this function, and then we're going to plug in 1,000. So what is the derivative of this? Well, so c prime of x is going to be equal to, well, the derivative of 54,000 is 0, so it's going to be 0, but we're not going to write it. The derivative of 200x is just 200, plus the derivative of 4x to the 3 over 2. And so the derivative of this is going to be 3 over 2 times 4, which is going to be 12 over 2, which is 6x, and then we subtract 1 from 3 over 2, so it's going to become 1 half. So 6x to the 1 half. So this is going to be our function, 6x to the 1 half. Then we're just going to plug in 1,000. So 200 plus 6 times 1,000 to the 1 half. And so you're going to get 389 point, and we're rounding to the nearest cent, so it's 736, but this is going to make it a 4, so 389.74. Now we're trying to find the production level that will minimize the average cost. So in order to do this, what you want to use is the formula c prime of x is equal to c of x over x, and then we're going to solve for x. So c prime of x is equal to 200 plus 6x to the 1 half, and then c of x is going to be this function right here, and then we're dividing it by x. So 54,000 plus 200x plus 4x to the 3 over 2. Then we're dividing by x, so this is just going to become 54,000 over x plus 200 plus 4x to the 1 half. And so now that we got this, we can just simplify. So these 200s can cancel basically. And then if we minus 4x to the 1 half to the other side, we'll get 2x to the 1 half is equal to 54,000 over x. Then if we multiply both sides by x, this is just going to become 2x to the 3 over 2, which equals 27,000. Or no, equals 54,000, but then we're going to divide by 2. So it's just going to become x to the 3 over 2 is equal to 27,000. And then if we solve for x, we're going to get that x is equal to 900. So x equals 900, that's going to be the answer to D. But then how do we find the minimum average cost? So what we want to do is take, we're going to do c of x over x, but instead of x, we're going to plug in 900. So c of 900 over x, it's going to become, we already have that here. This is going to be it. So it's going to be 54,000 over x, but we're using 900, plus 200 plus 4 times 900 to the 1 half. And so let's plug that in our calculator. So 54,000 divided by 900 plus 200 plus 4 times 900 raised to the 1/2. So if you do that, you'll realize the answer is going to be 380. So 380 is going to be the answer to this problem, and so these are going to be the answers to this problem.